Before I start the main topic of this video, I'd like to explain something. You're probably wondering why am I wearing this headset. It's to be able to record my voice in a much clearer voice, instead of hearing the quiet and slightly echo type voice I would have had if I wasn't wearing this and just using a regular external mic. Also, I apologize in advance if I pronounce anything wrong because there are a lot of scientific words that I might not be able to pronounce correctly, and I apologize in advance once again. Anyway, begin with the video. There are many questions on how the universe began. I'm going to explain one of the most accepted theory by experts, the Big Bang Theory, not the show. First of all, what is the Big Bang? The Big Bang was the beginning of the universe, how it all began. Before it, there was nothing, and it occurred over 13.7 billion years ago. Crazy, huh? When it occurred, there was something called the cosmic microwave background radiation, which I will get to in a little bit. After the background radiation, there was a period called the Dark Ages, which lasted about 400 million years. The first stars started to form after the 400 million Dark Age. Then, about 7 billion years after the Big Bang, galaxies finally began to form. Then, about 3 billion years ago, dark energy accelerated expansion began. Dark energy is the form of energy that we believe to be the reason why the universe is expanding at an accelerating rate. Nothing else is really known about dark energy. Since we really can't see it, we can't study it all that much. We accept the Big Bang Theory because of the extrapolation of the expansion of the universe backwards in time using general relativity. It yields an infinite density and temperature at a finite time in the past. Basically saying, if we rewind the universe expansion to the beginning, general relativity tells us that at one point there was nothing. Now, on to the person who first proposed the Big Bang Theory. Contrary to popular belief, Edwin Hubble was not the first person to propose this idea of the expansion that the Big Bang Theory explains. A Belgian priest and professor of physics by the name of Georges Lemaitre was the first, publishing his expansion theory article 2 years before Hubble did. Early in the video, I mentioned general relativity. It plays quite a big role in the Big Bang Theory. As I said earlier, it helped us figure out at one point there was nothing. Not even time. It was published by Albert Einstein in 1916. A fun little fact about the famous equation of E equals mc squared is that it is in fact incomplete. The full equation is E squared equals mc squared squared plus p times c squared. If you'd like to learn more about this equation, I suggest youtube.com/user/minutephysics. Anyway, back to the Big Bang Theory. The framework for the Big Bang model relies on general relativity, on simplifying assumptions such as homogeneity and isotropy of space. Homogeneity means uniform structure throughout, and isotropy means uniformity in all orientations. Obviously, there were theories before the Big Bang Theory. The most accepted theory before the Big Bang was the steady-state theory. The steady-state theory proposed that new matter was continuously being created as the universe expanded. This theory is now dead, so don't rely on it. The Big Bang scenario best fit observations after the discovery of the cosmic microwave background radiation in 1964. The cosmic background radiation is usually explained as radiation left over from an early stage in the development of the universe. It's like a birthmark of the Big Bang that we can study to learn more about it. Now, let's go into the miscellaneous stuff about the Big Bang. There are many misconceptions about the Big Bang. Let's go into a couple of the most common ones. Most people today imagine the Big Bang as an explosion, hence the name Big Bang. However, experts say there was no explosion, but a very, very quick expansion. Imagine a tiny balloon as the point of the center of the Big Bang, and then inflate it very quickly in a fraction of a second. No explosion, just a very, very fast and very quick expansion. People tend to imagine the center of the universe as a little fireball floating around in space. According to experts, however, space didn't exist prior to the Big Bang. The point didn't appear in space, as space was in the point. We don't know exactly where or in what the point was formed. We just know it was the point of the Big Bang. The Big Bang theory isn't the only theory out there. It is only the most popular. There are many other theories that have been created throughout time. such as the steady state theory that I mentioned earlier. But let's talk about another type of theory. If, based off observation, someone can construct a spherical, symmetrical universe with Earth as its center, you can only exclude it on philosophical grounds, making the Big Bang theory acceptable. Now, let's talk about the fate of the universe real quickly. Since this is a video about the Big Bang theory, I'm not going to go too much into this, but I might as well skim it because it does relate to the Big Bang in some way. Now, there are three theories that we believe that can be the fate of the universe. Well, the three most accepted theories: the Big Freeze, the Big Crunch, and the Big Rip. The Big Freeze is generally the most accepted theory for the fate of the universe. In around 10 to the 14th power years, a really long time, way after we're gone, all existing stars will burn out, and new stars will cease to start. Eventually, and over a longer period of time, galaxies and black holes will begin to evaporate. Nothing new will be created. Everything will go dark, thus freezing time. Thus why it's called the Big Freeze. The Big Crunch is where the universe expansion reverses its expansion, basically reversing the expansion of the universe, shrinking and shrinking and shrinking, and getting crunched back to when it was the Big Bang. Thus, just crunched together back into the single point that the Big Bang was. And finally, the Big Rip. This theory says where the energy density of dark energy increases without limit. This is the only way this can happen. And if it were to happen, eventually, this dark energy density will be too much for anything, not even gravity. Everything will just tear apart, the universe will tear apart. That's why it's called the Big Rip. Everything just rips apart. I hope you enjoyed this video about the Big Bang. I did have fun looking up research about it. I learned a lot. Sort of. I did know about the Big Bang and the stuff, but you get the point. I learned stuff. Well, it's been fun, Mr. Wood. I truly did enjoy Astronomy 2. Thanks for being a fun teacher in this class, as well as in Astronomy 1. Once again, I hope you enjoyed this video, and see you later.